Okay, so the first problem we want to look at today is the problem of some toolkit functions. Can't do them all, but the exponential function. Now, it's form for the exponential function. Y equals 2 to the x. Okay, everybody got that idea? This thing wasn't zoomed. Hang on a minute. Okay, so again, we have our basic exponential function, y equals 2 to the x. Just to quickly review. We always start with -2, -1, -1/2, 0, 1/2, 1 and 2. Meaning we're gonna set up our x-axis this way always, okay? And then our y values, without going through the details, we get 1/4, 1/2, and we can't evaluate. I'll just write in here, there's no exact value. And actually, that's not quite true. There is an exact value. We just don't know what it is. Okay? And let's be correct about this. Now, I say exact value unknown, I'd be more correct if I said the exact value can't be calculated. It can be approximated, it can't be calculated. It can be approximated as close as you want, can't be calculated, so you can't calculate it. I can't calculate the exact value. No computer on earth, put them all together, can calculate the exact value because it never ends. Okay? Then you get 1. Exact value is unknown here. Then you get 2 and you get 4. Okay, so if x is, well, x goes from 1/4 to 4. So we're going to want to divide our y-axis up to 4. We're going to want to put marks for 1/2 and 1/4. Then we can plot our points. And that's our basic function. Okay, now I use terminology, you don't have to know this, but I do use terminology. That's a basic function. Its domain is -2, -1, 0, 1, 2. Its range 1/4, 2, 1, 2, 4. The y values form the range, the x values form the domain. Then I extend the function, and when I extend it, means I sketch the curve. That's the points. And now the domain goes all the way from -2 to 2. And the range goes all the way from 1/4 to 4. That's worth remembering that for purposes of pre-calculus. I might ask about that on the exam, but if you don't know that much, it's okay. But I do want you to be able to graph these and answer some questions. Okay. Now, if we look at the handout, series of questions in this thing. So we want to find And of course, I emphasize on the test, I want to see the full details of these calculations. I'm not going to take the time today to do this, except to give you one example. Now we would two to the negative 2 means 1/2 squared, which is 1/4. So that's where we get the 1/4. Okay. So I want to see those details because they get right to the rules for exponents, which are extraordinarily important throughout the course. Okay. So make sure we've got those details. And then it does ask what the domain is. Okay. So I'm going to write the domain as a set. This set, we use braces to list the elements of this set. It consists of -2, -1, 0, 1, 2. In the range consists of your y values, 1/4, 1/2, 1, 2, and 4. The domain of the yellow curve, and writing the domain of the basic function, the 5 points that you get for this function in blue, right? And in yellow, I'll write the domain of the curve, which is the interval. I'm going to write it this way. It's all x's between -2 and 2, including -2 and 2, which is the interval -2, 2. That's terminology I think you've seen. Range is your x values from -1/4 to 4. That is the interval. One, 4, 4. So the question didn't ask about the domain of the yellow curve, but if you want to add that in, it's great, if you understand it, okay? So you got two things. You got the 5 points, and then you've got the curve. The curve approximates the actual function in this area. And then, of course, the thing can be extended beyond 2, all the way to infinity as far as that goes. And back this way, all the way to -infinity. Okay. Okay. So that's at that point, you're into the pre-calculus. We don't need to go any further here. Just trying to, the last couple of weeks, give you a little introduction to some of the important things you're going to see in pre-calculus. Okay, now. Number 12 asks you to do something for a different toolkit function, okay? And that one happens to be the basic cubing function. Well, I don't want to take class time to make the table and go to all the details. So I'm just going to use the graph of the exponential function. So I'm probably going to need a little more room. And I'm going to do this kind of quickly because some of this stuff we didn't do. Matter of fact, I'm not going to do number 12. You're not going to see something like that. I'm not going to ask you those questions, but something I might ask that isn't there on number 11. I might ask you to estimate let's put it this way, if f of x equals 2 to the x, estimate f of 3 halves and the solution to the equation f of x equals 3. I'm going to ask you to see if you can do a little bit of that. Okay, great. It's our last day of class. I'm going to miss you guys. I'm going to miss the guys that aren't here. I'm already missing them. They're not here. Okay. Some of them probably don't need to be. Some of them might have conflicts. I don't know what happened to them. But I'm glad everybody that's here is here. Okay. Y'all have been a great group. You know, this is one of the best groups I've had as far as people staying on task, working positively, working with each other. So I just want to say that. And those of you who aren't here, if you're listening to this, it applies to you too. Okay. So it's been a great group. As I said, I'm going to miss it, but I hope to see some of you in my class. Now, there are other sections of these classes, so I don't expect all of you will show up in my classes. Some of you might have better judgment than that. Anyhow, y'all did real well with this. And one of the big things in pre-calculus is understanding graphs and what they tell you. Okay? Now, I had to give most people a couple of hints, but it's interesting the way this worked. You know, but one question I would ask is, okay, we want to find f of 3 halves, right? So what's f of 1? Okay, well, the table tells you that the table could be written this way. X, y, and y equals f of x, which is 2 to the x, right? So here are your x values. Here are your values of f of x. So if you want f of 1, well, there's your table. Tells you that f of 1 is 2 and f of 2 is 4. Okay. Then, you know, if I ask you to point it out in the graph, say, well, f of 1 is 2, so here's 1 here. Okay. Yeah, there's f of 1. There's a point on the graph. There's, can I say f of 1? There's 1. Here's your point on the graph. And over here is f of 1, right? Okay. And now, where's f of 2? Well, really point here. Yes. And then it's okay, where's f of 3 halves? In one case, I heard, aha. Okay. And that's very rewarding. Okay. It's good. Now, in another case, somebody's thinking about the progressions here. Okay. And that's a really good thing to do too. You know, the progressions are that, well, you increase by a little bit here, a little bit more here, a little bit more here, and a little bit more here, right? Numbers are increasing. So if x becomes 3 halves, that's between 1 and 2. Okay. Can we solve that? You know, I didn't have to prompt anybody to do that if I brought that up. Okay. Between 1 and 2, so that, well, what can you tell me about f of x? Well, it's between 2 and 4. Okay. So just looking at the numbers, and that's a very good thing to do. Trying to see the progression in a set of numbers. So kind of work with that idea, enhance that idea. Okay, it's a good foundation. And if you're not looking at the progression, think about looking at the progression. It's a really good thing to do. Okay, so now what do you do on the graph? Well, if f of 1 is 2 and f of 2 is 4, so well, f of 3 halves, of course, 3 halves is 1 1/2. Put it right there. And I think everybody knows that. So we put out 3 halves here and project over here. And this should be about f of 3 halves, right? So here is, I've got my graph. Okay, and that looks like a little less than 3. Now, if you're looking at the progression, well, halfway between 1 and 2 is 3/2, right? Halfway between 2 and 4 would be 3. But since if you look at the progression, the changes keep getting bigger and bigger every time you make a jump, you expect this is going to be a little less than 3. Now, if you have a really accurate graph, and this is not all that accurate, okay? But if you have, this is a pretty accurate graph. Now my 3/2 is a little too far over. It should be halfway between 1 and 2. So I didn't actually cheat to get that over there. It just happened. Okay. But you can get a pretty good estimate. Now, an honest estimate of this, if this is 2 and this is 3, that looks like 2.7 to me. Okay. So I'll say that's maybe 2.7 from the graph. Okay, so it like this. The graph, the f equals 3/2 point, looks like about 3/2, 2.7. Okay. Now I know that for significant figures, it's 2.828. Well, I don't have room to write out 2.828, and that's just another one of those things I can't forget. Square root of 2 is 1.414. Double that, you get 2.828. And also, I'm using the rules of exponents. 2 to the 3/2 is 2 to the 1 times 2 to the 1/2. It's 2 to the 1 plus 1/2, right? Which is 2 to the 1 times 2 to the 1/2, which is 2 times the square root of 2. So that's how I get the 2 times 1.414. And again, you know, back in the ancient days, it was really handy to always know what the square root of 2 and the square root of 3 were. It came up very often. And we had to do a lot of stuff with numbers using logarithmic tables and all kinds of stuff that you can be thankful you don't have to do, although we learned a lot about logs and stuff. It was ingrained. But you can learn a lot about logs without having to do all that pain. Okay, so anyhow, that digression aside, do we understand how that's estimated? And you understand how you could estimate the value of any of 2 to any power? I just said, well, what's f of that power? And your graph will tell you. Usually, if you got a good graph, you can estimate it with a plus or minus a 1/10. So even though I got the 3/2 over a little too far this way, which gave me a little bit of a low estimate, I still was within about a 1/10. Okay. And rounding off 2.7 versus 2.8. Okay. Now, solution to f of x equals 3/2. Well, f of x is the y value, right? So you're going to have to find where f of x is 3/2. Again, the graph is getting closer, but I can kind of do this. Okay, so you put 3/2 here. Okay, that's the value of f of x. You find the graph point that corresponds to this value. We just sit on over here and come on down here and take what you got. So what do you think that looks like? Well, this is a half, this is 1. Looks like between 2.7 and 2.8. Okay. It looks a little closer to 2.8. not 2.8, to 0.8, okay? So there's for x equals 0.8. And here is f of x equals 3/2. Now I've got to figure out a good place to write, and I'll write it all the way down here and then use an arrow. Okay. So the red f(x) equals 3/2 means y equals 3/2. So we find the graph point. Find the graph point for 3/2. We estimate that it's 0.8 3/2. I'm having trouble writing through this chart. There it is. Okay. So this point would be 0.8 3/2 gives you the answer to this question, solution to this equation. And this point here would be 3/2, 2.6. So if you understand that, right now, you're in pretty good shape, because when you see questions like this later, you'll be well prepared to answer them. Now there's even a little more I can say. I'm gonna say it. Ouch. Okay. Didn't hurt that bad, but it's a constant. Okay. I hate to be clumsy, so it just offends me. Okay. Equation 2 to the x equals 3/2. Okay. Now in pre-calculus, you learn to solve that equation. You can't do it using intermediate algebra. Okay. So something to look forward to is learning to solve that equation. And it's not all that hard when you get to that part of pre-calculus. Okay. Turns out you're going to need a calculator. But just any old calculator will do. You just have to have a calculator that does logs and exponential functions, and almost every calculator does. It'd be hard to find a calculator that doesn't. Okay. So you don't need a fancy graphing calculator. Now you might need a fancy graphing calculator depending on which calculus class you take. Okay. Wouldn't need it in mine. I'm not trying to lobby you to take my course, and I'd love to have you. Okay. Take the course that works best for you. And there's an argument for calculators. I think they're so overused. I don't like to use them, because if you learn the pre-calculus, it takes you like 20 minutes to be able to do it all on a calculator. You can learn it in 20 minutes. Okay. But using a calculator, I think you never really learn pre-calculus if you don't use it, if it's misused. So I'd rather have you learn pre-calculus. Then learn how to use your graphing calculator, okay? As opposed to shortcut the learning process in pre-calculus using the graphing calculator, so you get answers you don't understand, things you don't have a comprehension of. Oh, that's my soapbox. I'll stay off of it, but that's kind of a philosophy for trying to choose a course. And I could be right or wrong. You know, if you want to shortcut stuff, if you love using the calculator, you'll get a good course. But if you do, you keep talking, I said I'm going to get off my soapbox. If you do take a course where you use the calculator, make sure you're not using it to shortcut the learning process. Don't use it as a crutch, use it as a tool. And that's really difficult to do because everybody's used to using it as a crutch. Okay, so, but I don't discourage you from trying. Okay, just keep that in mind. Okay. Okay, well, gratifyingly, everybody had to think just a little bit. Some had to think a little longer than others, but just, I didn't really have to tell anybody how to do it. Okay, it's very logical. You know, this means 1 over, because that means that, right? And then it's over all of this. Now, nobody wrote this out, but you could have written it as 1 over x plus 6 as an intermediate stage. There it is, and that's what everybody got. Okay. And that kind of reinforces my philosophy that this project that I've spent probably 400 hours on, interpreting things from this notation into LaTeX notation, was unnecessary. But it's all right. I said I'd do it. So it was going to take me maybe 10 hours to write a program and do it, and it turned out to be much less feasible. Because there's one thing I didn't think of, which was how do you find the beginning of a series of slashes? Okay, the beginning of the expression there's too much ambiguity there, so I didn't. Yeah. Anyhow, that doesn't matter because the output that I'm getting is looks real nice. Okay. I don't think you should be teaching mathematics by how it looks, but everybody wants it to look nice. So I hate to disappoint it. So I made it look nice. Okay, anyhow. Okay. And as I say, it was worth doing. Okay. Anyhow, now we want to simplify this, right? Well, fraction means we're dividing, right? It means we're dividing 1 by 1 over x plus 6. Well, if you remember the rules for fractions, then you have to, because you're going to have to use them again and again in pre-calculus. You invert and multiply. Now you could write this 1, if you want to, as 1 over 1. Just to remind yourself that you multiply numerators and multiply denominators. And write it out in more detail than really necessary, but avoiding things like a vague concept of cancellation. We write that as 1 times x plus 6 over 1, but then 1 times x plus 6 is x plus 6. If you divide something by 1, you still get that same thing. So this is just x plus 6. Okay. So I didn't give you time to show me that you knew what to do there. So let me get on to some other things, but I think everybody understands that. If you just remember the rules for fractions. Okay. Okay, let's see what else we need to look at. Okay, there's a more extensive version of this. And if you want to see a more extensive version, just email me. I'll throw it into the announcements for your course. Okay. But the basic idea, and this is not, something I expect you to have totally mastered, but it's something, again, I want to get your brain working on a little bit. Okay, the domain of y equals the square root of x minus 8. Well, can anybody show me with their fingers a number that x can't be? If we want to get a result here. Okay, x can't be 0. Okay, so let's, you're right. Let's talk about why x can't be 0. Okay. X can't be, well, I asked, and somebody told me x can't be 0. Okay. Oh, why can't x be 0? Back to 0, the square root of x minus 8 is the square root of 0 minus 8. And what's wrong with that? Well, what's 0 minus 8? Well, it's negative 8. Okay. Now, what's the square root of negative 8? Okay. Well, the problem with the square root of negative 8 that's it into formal mathematical language. Ain't nothing you can square and get a negative. Okay. No, I say ain't nothing. Yeah, there is something. Okay. It'll be an imaginary number. Okay. So I'm going to kind of lightly cross out this and say no. No real number that you can square and get a negative. Okay. And since we're implicitly talking about functions of real variables with real values, it's not a course in complex variables. I'd love to teach it, but and so a decent course in complex variables is senior level course for math majors. Okay, so we're not going to do that. Anyhow, nothing you can square to get a negative. So you don't get a y value. X equals 0. And in order to have a function, we have to have an answer. Okay, so x equals 0 isn't in the domain of y equals the square root of x minus 8. Okay, so anyhow, what numbers could be in the domain? What number could you put in for x that would give you a y value? Well, so there's well, x equals 9. Yeah, okay. square root of 9 minus 8 is the square root of 1, which is 1. Matter of fact, any number greater than 8 is in the domain because you're greater than or equal to 8. Even if you're equal to 8, if you're greater than 8, you definitely get a positive number when you subtract 8. If x is equal to 8, you get 0, but the square root of 0 is 0. 0 times 0 is 0. Okay? Okay, well, we can summarize all this. By saying, well, we don't have to try a bunch of different numbers, although it helps to do that. In our head, it helps to think about what numbers wouldn't work here. But then once you understand that, you can make the formal argument. X minus 8 can't be negative. Again, you play around with numbers and figure out why this quantity can't be negative. So x minus 8 has to be greater than or equal to 0. And if x minus 8 is greater than or equal to 0, boy, this camera, it's not the camera. Okay. Just didn't zoom back as far as I thought. So x minus 8, excuse me, x minus 8 has to be greater than or equal to 0. Well, it's a simple inequality. We add 8 to both sides, right? And that tells us that x is greater or equal to 8. Now, we could have figured that out without going to a lot of trouble, but it's a more complicated expression in there. You can always just set it greater or equal to 0 and solve the inequality. Something you'll do a little bit more of in pre-calculus. Okay. Okay. Well, we got all the 7 minutes. Boy, I'm going to miss you guys. Okay. Not completing the square, I think. I don't want to confuse you with the application of quadratic equation. Pretty neat. It's beyond what you're going to really need to know. I'm going to kind of put a point on this example we just did. This very next problem asks you if f of x is negative 3x squared plus 5, then is f of p plus q equal f of p plus f of q. Unfortunately, I didn't get to, I didn't have this quarter on most of that. So not gonna recapitulate it now. When you leave, I'll probably go over it just so you have it to remember. I did say it's appropriate that I was trying to squeeze something into the board at the very last instant in the class, since you've seen me have to do that so many times during the course. Okay. One thing we'll say now, remember, if you do decently well on the exam, then I can recommend that you would be able to take the pre-calculus without the co-requisite. Still might be a good idea to do it. Depends on how confident you are. And I might even leave it up to you, say, you know, I can't say that you're not, but I can't say that you are. You decide, okay? And if you want me to make that recommendation, I would. Or I could say, yeah, you don't really need that prerequisite. You still need some more help, okay? And I think out of the class, it runs about 50-50 right now from what I see. Many of you, yes, many of you, I think you're going to need a little more help, okay? And that's half of you probably okay. Half of you probably need help. And the other half, maybe. No, it's 3 halves, and I'll leave you with that. But see how well you can do on it. It will, at the very least, solidify a lot of these ideas and give you a head start in pre-calculus, okay? Okay, now what I think didn't get recorded was this problem. And it was kind of fun the way we worked it through. We'll have to do it. I don't have an audience anymore, so it'll probably go flat. But anyhow, got f of x equals negative 3x squared plus 5. We want to answer the question, does f of p plus q equal f of p plus f of q? It might. For some functions, it might actually work. But you know, here we had an example of one where it doesn't work. Your f of p, well, f of 6 minus 5 does not equal f of 6 minus f of 5. An example where f of p and f of q don't combine to give you an f of p and an f of q. Okay, well, in other words, as we said here, function notation doesn't distribute, so we don't expect this to distribute. Although I will say if this is a linear function, it would. Okay, it will distribute for any linear function. Well, no, it won't. If it's a proportionality, a direct proportionality, it would do that. You don't even know what that means. Okay, so here we have this and this. Okay, so f of p plus q, well, we're plugging p plus q in for x, we get f of p plus q, right? And that's, there it is, f of p plus f of q. F of p, substitute p for x, you get negative 3p squared plus 5. F of q, you're going to substitute q for x to get negative 3q squared plus 5. When you add those, you're going to get a negative 3p squared, you're going to get a negative 3q squared, and you're going to get a 5 and a 5, which adds up to 10. At this point, you can already pretty well tell that this isn't going to be equal. Maybe for some values of p and q, it'll be equal, but it certainly won't be true for all values of p and q, simply because 5 and 10 are different numbers. So unless p and q, unless the stars align just right, so that negative 3p squared minus 3q squared is 5 less than negative 3 times p plus q quantity squared, it's not going to work. Okay, well, now one reason we're doing this is because you do see things presented in symbol form in pre-calculus. You need to understand how to work with symbols. Okay, so working with these symbols, we get these expressions. Now, we want to set this expression equal to this and ask if that equality is true. Is this, which is f of p plus f of q, equal to this, which is, I'm sorry, is this, which is f of p plus q, which is here. Okay, I'm writing it out, I know where it is. I wrote it out 10 minutes ago, so I don't know where anything is, I'm sorry. Okay, anyhow, here's your f of p plus q expression. Here's your f of p plus f of q expression here. That's what we have, okay? Is this expression equal to this expression? Doesn't look like it is because you got a 5 here and a 10 here. And you can actually draw that conclusion, but let's work it through because usually you have to work it through to actually prove something. Okay, so we square the p plus q by writing p plus q times p plus q. That's the only change we make in this equation from here to here. We just replace p plus q squared with p plus q times p plus q to emphasize that we do this using the distributive law, not some formula. And If we use the distributive law, we get P squared plus 2PQ plus Q squared. Okay, so between this step and this step, we just replace the quantity P plus Q squared of what you get when you multiply P plus Q by P plus Q. So if this is true, then this is true. And if this is true, then this is true. Well, we can take this a little further. We distribute through by the -3. And we get -3P squared minus 6PQ minus 3Q squared plus 5 here. The right-hand side hasn't changed since we wrote it down. Now, at this stage, I didn't have room to write any more steps. I just observed that the -3P squared matches the -3P squared on both sides. And the -3Q squared, that's a bad look at Q, although it's kind of tough in context. The -3Q squared and the -3Q squared match. So I could just add 3P squared and 3Q squared to both sides. They would go away, leaving me with -6PQ, the 5, and the 10. So we'd have -6PQ plus 5 equals 10. Now, if we subtract 5 from both sides.
Are you teaching right now?
Look, I can stop this because I'm just about. Well, I was recording. That's not a problem. I didn't have a recorder on at the end of my class. So I'm just,
It's code on finish up.
this,
Okay, all right.
yeah,
That's all I need to know.
there's really, I can't say for sure. You never know because the guy's smart. It's not
Okay,
remotely on track. I hope you'll get on the trial this summer and do it.
okay.
So we can,
Well, I offered him to finish up my 2 classes in the summer. But if he's got to do that and your stuff still this summer.
I don't see him.
Okay.
But he can, I give him a little extra time after the summer. If he's trying to do all that.
Yeah.
I mean, he's put in the time, he's been enthusiastic,
Yeah,
but.
Yeah.
Or enough of it.
I think he's pretty burnt out.
So,
You know, yeah. I mean, this is his 3rd year. His work,
yeah, well, it's obviously got a time problem, whether he doesn't know how to manage or just doesn't have it. He's got some family stuff, he did that to the first day he passed away.
Okay.
So it's not incapable, but, just. Yeah, he's. I talked to Jason, I talked to Jason, so that's good.
At least that's one we don't have to worry about.
Yeah, but I don't know where it stands in Belfast.
He has to retake 2 of my classes.
Always going to retake more.
Yeah, completely retake them. I was going to offer them independent study.
Yeah.
So if he wants to just focus on the schoolwork this summer, he can maybe do that. If that's all he's doing. If he's going to try to work too. See that.
Well, easy on, we'll hurt him, but spend another year and get himself really ready.
Yeah.
I've seen just a lot of deficiencies in students. Not recognizing the quadratic equation, stuff like that. So I want to go with that. You guys have a developed mathematical tool. You can't not know integration by parts at this stage. You can't not know, well, I could list 3 dozen things in the time. So at that, one is probably I think that's it.
I don't think you want to engineer.
Yeah,
Oh, and you got to go.
Yeah, I've got the code. Actually, it's not much right now, but he's pretty good. He's got actually real efficiency. He's very smart. And he's wanting to transfer the techniques.
What's he going to study?
And
He's going to study electrical engineering.
Yeah.
I didn't go through this. He's going
Probably
to start all
because,
over.
probably because, probably ought to talk to me today. But he's got to show up here.
You can't do the sophomore class too, does the freshman classes. Can't do that,
Yeah, well, he has the calculus.
I don't know. Hello? Hi. Are you his student? Maybe.
Yeah.
Are you the one who wants to study electrical? Yeah. You know you're gonna be up there like 4 years. To study electrical engineering. Because of the way the prerequisites. Might do it in slightly less. Have you thought about that? Is that okay?
I thought it was 3, but it's 3. So like
Three?
engineering is about a 5-year degree on paper. And so I had this associate's degree up against
In science.
yes.
But you haven't had ENGE 1215 or 1216, so you have to do those. They won't let you take any sophomore classes, I don't think, until you've had those done. What are you gonna take with those next year?
I have no idea. I was going to take so I talked to the guy that set up my schedule here, and let's get the science.
Michael McBride?
Yeah.
Okay. You know, when all else failed, I mean, if you're gonna figure out somebody who's probably set up a schedule, the odds are it was Michael McBride here, so it's a pretty good guess. And you had chemistry?
I'm taking Chem 1 and 2 right now.
Okay,
Well, finishing up Chem 2.
okay. And what math are you doing?
His math is, it
Top
needs
three.
differential equations.
These differential equations.
Assuming,
Well, they ain't no assuming it's gonna happen.
I know.
It's gonna happen.
I trust you.
Have you looked at what was your program tech?
That's right here.
All right, so. Six. It's not this. It's not this. That's mechanical. Yeah, that was. So what you're going to do, can I just electrical?
Well, I can do either, but the electrical, I think.
You have an electrical check sheet. I tell you what, if you're wanting to talk to Mr. Smith, talk to him. I'm right here. Come see me.
Just now, he's
Right.
trying to
Yeah.
drive him. My bad. I'm
Well,
sorry.
you guys can talk. We need to run over a little bit.
Well, you got me really concerned, so I think I definitely need to talk to you sometime.
All right, I'll pull up the double E degree and come check it out.
Okay. And I'm not 100% sure on tech. You know, Western Carolina University is also a school that I've looked at.
Okay, have you applied to either?
Yeah, I got accepted into Western, so I'm not sure.
Western, but not tech.
Yes, I haven't just heard back, not yet. And I think I'm probably gonna get waitlisted again. So, Western's more than likely where I'm gonna go. Okay. So that's a little different, I'm sure, right?
You know, a little bit different program. I haven't looked at it, but I'm gonna pull it up, look at it and see what you're looking at.
Thanks, sir.
All right. Yeah, we'll nail the physics when you're done.